what I really mean is a 20% sale. 20% sale, and with an additional 10% off, and then you get a further incentive, you get minus $5 off at the register. Okay, now 20% sale means that you're going to pay what? 80% of the original price. So if you buy an item for say $100, you're going to be paying 20% off of $100 is $20. They're going to be paying $80. Now we can represent that first thing as f of x is equal to 0.8 of x. So as I mentioned, if you take f evaluated at 100, that would be equivalent to 0.8 multiplied by 100, and so the price would be 80 bucks. Okay, but now we're going to take an additional 10% off of the sale price. So if we took this $80 and took another 10% off, we take $80 minus 10% of $80, and that would be $80 minus what? $8, and so you'd really be paying $72. But then, at the cash register, you're going to be subtracting another $5, so your final price is going to be $67. Now the question is, can we represent this as a function, or composition of functions? Well, the answer is yes, if we think about it for a moment. We can think of the g function, function g, representing the amount that we're going to get if we have 10% off, an additional 10% off. So the g function can be represented as 0.90x. Because if we get 10% off, we're really paying 90% of the price. So we can combine the g function with the f function in such a manner so that we take, we look at the composition of g with f of x. So what does that mean, g of f of x? It says the g function is going to be evaluated at the f of x function. The f of x function says whatever we got, we're going to multiply by 0.8. It's going to be 0.8 of whatever x is. And the g function says take this input and evaluate it at 0.9 times the input. So we're going to take 90% of the 80% of x. Now what's this going to give us? 90% of 80% is going to give me 0.72 of x. So when we combine the function this way, we get one single function that gives us the price at the checkout before we subtract our $5 off. So we call this type of ways to combine functions composition. And so when we see g evaluated at f evaluated at x, it simply means g composed with f evaluated at x. And that's what the definition of composition means. G circled f evaluated at x. All right, so instead of having to go through these intermediate steps, the composition function just simply says multiply the original price, whatever it is, by 0.72, and that's going to be the price before you take off the additional $5 at the checkout. Okay? So that's called composition. Now for composition to be valid, we have to have x has to be in the domain of f of x, and f of x has to be in the domain of g of x. So both these things have to be true. Let's take an example. Suppose f of x is equal to 2x cubed plus 1, and suppose g of x is equal to 3x minus 5. Okay? what would g composed of f of x really be? All right? The g function is our outer function. And the g function, we can think of the g function as the function which says 3 times the input minus 5. Now the input is going to be f of x. That's what this says, f of x. So we're going to multiply 3 times f of x minus 5. So what is f of x? F of x is the function which says 2 times the cube of x plus 1. So this is going to be 3 times the quantity 2x cubed plus 1. Then we're going to add or subtract 5 in this case. So when we compose the functions g with f of x, we're going to have 3 times f of x minus 5. Let's simplify. Distributing the 3, we're going to get 6x cubed plus 3 minus 5. And we're going to get 6x cubed minus 2. So the composition function, g circle f, is a brand new function which is made up of the 2 individual functions, f